So now let's continue on to the next topic I want to cover today. The reason why I break this video into two is because it's a totally different topic from what I said earlier. So that's why this is a separate video. And this is required for your project. So I'm going to expand on it and how to use Git or GitHub, basically. You might have heard about it. I will begin by first motivating this case. So let's switch gear and imagine you're working on a group project and you spend the last 7 days cramming the code in. This is typical, basically, to be honest, this would happen, right? I mean, I do run into this scenario quite a lot, right? It's a group project that are 2 weeks or 1 week project, and I have to get it correct, right? It's a lot of work, right? And you finally get everything to work and plan to do a pilot run. And you create a directory to store the results, blah, blah, blah. And you make a typo and you accidentally type in rm-if and hit enter. Okay, so for those of you who used Linux before, this basically remove everything in the current directory where you are. And you're going to get that, right? Your file are gone. Yep. This can happen. Really, right? Another thing that can happen, I think, is like you're working again, same setup, group project. 7 days of being cramming the code in, you finally get everything to work, and now making some changes to get rid of one bug that are left, right? There's one thing that still make the program incorrect, and you're like, hey, that's a bug, I'm gonna fix it. You try to change the code, you fix that bug, but you create 3 more bugs as a result of that. And as a result of fixing the original 3 bugs, you create 10 other bugs while debugging the old bugs, right? And I mean, this can happen as well, right? I mean, hopefully as you grow as a programmer, this would happen less and less and less time. But let's imagine this guy who's been working on a project and he is probably sitting silently in the corner right now, wishing that you can revert back to that old version of 1 bug so you can maybe at least compare the 2 versions, right? Sad face again, right? This can happen. Or things like you say, hey, I swear my code worked yesterday. I shouldn't have deleted or rewritten any part of my code, or my computer crashed and I lost all my work. Or I work with my friend and he accidentally deleted my code, right? So these can be a sad things that can impact your grade, to be honest. And because you don't want this to happen to you, so don't use these as a reasons, because we're going to learn how to use the version control systems, or VCS. What are VCS? VCS, as the name suggests, is a version control system. It's a system that allows you to control different versions of your code. It tracks all the changes. It essentially allows you to go back and forth in time. Even when you accidentally deleted everything, for the most part, there are ways you can recover that. Unless you're doing something super catastrophic, it should still be recoverable. It also tracks people's individual contribution to the changes. So in this case, I say you work in a group project. I can see who changed what at what time. I can see who did what, and you can see who commit that part of the code that's buggy. So you can talk to that guy like, hey, I know you're trying to change this code, but it's buggy. I want to fix it, but what are you doing? So I know exactly how to fix that problem. All right. And there are multiple different software that are called, I guess, version control systems. If you like older, right? Back in say 2000s, right? That those years, SVN or Subversion is actually popular and used. We use this a lot. Many companies also use another software called Mercurial. I've seen people use both of them for different purposes. And one of the most common version control systems you might see nowadays is called Git, G-I-T, Git. If you don't know now, hopefully you know what Git is. It's a version control system. So we are going to talk about what can we do with Git. Git is a distributed version control system. It has an ability that your own computer which is a local machine, has its own local copy. And you can maintain multiple copies of the code on multiple machines. That's why it's called distributed. You can distribute it everywhere. And there's no need to talk to a central server when you edit the local file. Unlike Google Doc, where you are editing something and you have to connect to the internet, you can make change locally and only periodically sync with the central server, right? So this is a really, really good balance of collaboration and working independently. So you can work at your own pace, you commit the code whenever you want to commit. And to be honest, for those of you who want to work in the tech industry, make sure you know how to use Git. It's used everywhere, right? This is like a basic of the basic of the basic. If you don't know what's Git, you have a problem. You have a big problem. You need to know how to use Git. Git is one of the most popular distributed VCS. The benefit is allow you to easily branch and merge different versions of the code. It has a really flexible workflow. It can provide a way to check for data integrity, and it's fast. So it's kind of like a best of all things you want in the version control system. The basic of Git is where you store the code is called repo or repository. These are a collection of files and folder that have all the version history. So you have logs of the change, and you can revert back and forth between different versions. You have the file history that appear in snapshot, right? The beauty of this is now I can also, like, as a lecturer who can grade your own code, I can see the snapshot at different time where you commit the code. Think of this like when you play a game. So I believe that at least most of you here have played some form of game before. So when you're playing a game, somehow occasionally you can go and have to fight a boss in the game, right? So one of the most common thing that you would do if you're a sane gamer is you would save the game so that you can fight the boss, and if you lose, you can load the game back and continue to fight on with different techniques, right? We call this a snapshot, right? This is called a commit. And then the repository can have different branches, each with their own history of development, and you can merge and branch out again. This is a kind of like a brief overview of what I mean by version, right? You can have three different files that have different version of the file. File A has version 1, version 2, and the version 4. Basically, someone edit this file 2 times, delta 1 and delta 2. Someone also edit file B 2 times, someone edit file C 3 times. So in this case, you can commit different version of your code. Version 2 would have the delta 1 for file A, and C doesn't have any change to file B. So that's version 2, right? So version 4 can include the 2 changes to file A and that 1 change to file B, and and the 2 changes on file C. So this is good. You can actually now keep track of the history for all the file, right, for different versions. And to create a new repository, you can call the command git init, right? This would initialize a new Git repository, would basically create this hidden .git directory. You can clone existing repository using git clone and the repository name. This allows you to clone a remote repository to your local location. So here's a high-level explanation. This is kind of like the way you can modify your code, right? That's the version called the head. The head is the last commit. That's your snapshot. That's like when you save the game. There's index. Index is your proposal for the next snapshot. For example, if you compare to gaming, right? The snapshot will be the save right before the boss room. And your index, I guess, is when you fight the boss and won, and you think, hey, that's my proposal. Like after I win that fight, I'm going to save the game again, right? And the working directory is whatever code you're working right now. It's not saved. The one that's commit and snapshot is at the head version. So the command that deal with file. So let's say there's file A and there's multiple versions of file A, right? Something like this. You can actually move from the current version, the working directory. Basically, this one you haven't saved the file. This version 2, the newest version, you save it on your computer, but it's not in the Git repo. You can add this version to the Git repo by saying git add file name. That's the proposed change. Basically, I'm gonna stage. That's why we call it stage change. We stage that version 2 is gonna replace version 1. Then you can commit a change. Commit a change is I confirm that version 2 is gonna replace version 1 in my save game. You can do that by git commit -m. -m is a message you can put in quotation. This is the version 2 of the file. It has this new features or something you want to put in. If you have a change and you want to unstage them, right? You have v2 in the stage and you want to unstage that so that version 1 is now in the index. Revert back, you can do git reset and the file name. The head, whatever version in the head would replace whatever is in the index. If you want to replace it all the way to your current directory, you do git reset --hard. You discard the version 2. Now version 2 is gone. Right, now version 2 is gone. Everything will be replaced by the older version 1. You can also do Git status. The Git status would tell you the status of the Git repo. You will get the notification about these are the new file. You haven't added them. If you have files that are not staged for the commit, it will be said, hey, you modify this file, but you haven't really do anything with it. Please make sure you do something with that. There's also untracked file in the folder, but you haven't put command to that file yet, so it's untracked, right? So that's how you can manage the Git repo. And you can also manage different branches where you have different versions of the code. Master is basically most of the time this refer to the version that everyone would see. That's a master, like a master copy of this software. And then let's say someone branched this code, the master branch, the blue one out into the purple one and add some features, and the green one and adds another features, right? So you can switch between different versions by that would look something like this. You can do git checkout master. Git checkout master would basically check out the master branch. If you do git checkout branch 1, this is what's gonna happen. The head would now be at branch number 1. So you switch out the master branch into branch number 1. And if you want to generate another branch, you can do git checkout -b branch 2. This is basically now gonna create branch 2, right? So here's kind of like a visualization of what happened when you do checkout, right? So you can do git checkout master. Your current version of the file would be reflecting whatever is in the master branch. If you do git checkout some feature, switch back to some feature. If you have a server location like github.com, right? There's a remote location which is in github.com and your local location which is in your own computer. So there's a master version in github.com, and you can have the origin master or basically your local location of your master version. And it can also branch out to different branches, the develop branch and some feature branch, which you can merge later if you want as well. So when you have this server location, one of the commands that you have to deal with is called the pool. When you type in Git Pool will pull in the changes that are in the remote location, in the server, in github.com to your local location. This is really, really, really useful when you collaborate with your colleagues and your friends. Update the code, you can pull it into your own local location. So here's the overview, right? So when you type in Git Pool, right, what you are going to do is basically apply the change from the server. So I'm going to basically use more like a wording explanation. You bring in the change from the server to your local machine. When you want to push your own code from the local machine to the remote repository, you do git push. Git push basically would allow the code on your machine to be reflected on the server so that all your friends can see that, right? So here's a workflow summary. I'll kind of wrap it up by, if you have a new file, when you have a new file, do git add. And what I typically would do is I would git commit -a. Git commit -a would basically commit any changes that are tracked. So if you haven't tracked it, you do git add first. It would commit all the change to the head, right? So as you can see, it's this command, right? And then once you commit, it's in the local repo. You want to push it to the server, push it to GitHub so everyone else can see this change. You do git push. If you want to pull whatever is changed to the server to my own workspace, I would do git pull. Right? This is the head, this is staging, this workspace. All right. So what if you and your friends develop a code together onto a different computer and you make some edits? Your friend also make another different edits. And both of you want to update the server with the new code, right? This code version 1.A, 1.B, and you want to merge into version 2. You can do this Git Merge command, right? So before you merge, it's going to look like you have the master and some features right here. When you do fast forward to merge the branch, right? So that the master points to the current location. This looks simple, and it actually is pretty simple if there's not multiple people working on multiple branches where you do a three-way merge. Three-way merge is when master has its own branch and you branch out before this version. In this case, what you have to do is you have to merge this part with this part and create a new version that has been merged. Now you have one branch again. You do this three-way merge and the master will now point to this particular new node that merge the some features with the existing master branch. So here are some of the different Git commands that you will use. There's a command called init clone. Git status would get you information about the repository. Git log will view it allow you to view the history and commit messages. Git add would add files to staging area. You can commit them later. And push the change to the remote repository, the server, basically pull the change from the remote repository to your machine. You can check out specific version of the file, right? And that's it. Before I leave, I will say welcome to the IoT class at TGGS. For more information about Git, feel free to check multiple tutorial online you can do. And I would assume that you have the at least technical background to read text, right? There's many tutorials on how to use Git, and we are expecting that everyone have to use it. Why do we do this? So that you can version your code, so that you can commit the changes, so that we can see what are the changes. We'll use it for both your class, the project website and project's code itself. All right. Again, welcome to TGGS, and that's all for today's lecture, at least for my portion of the lecture.